Hello my dear students, welcome back to Learn Physics. In today's topic, we are continuing with the projectile motion. So last class we learned about the how to solve the projectile motion problems. One method we learned, right? So in today's video, another method to solve the projectile motion questions. Okay, there also we used the different components only used in last class also, and in today's video also we are continuing the same thing. Okay, so second method, that is how to solve the projectile motion type of questions. So projectile motion means we will be throwing an object with an initial velocity, and afterwards it will be moving with only with the help of gravity. Right. So since it is making an angle theta with the horizontal, this initial velocity can be given two components. So each velocity vector and the acceleration also will be there. Acceleration is gravity. So if the object is moving like this, then acceleration is acting exactly downwards. Okay, it doesn't have, so acceleration equals g, and in the upward motion acceleration we will be considering it as minus g. Downward motion acceleration will be considering as plus g, and here u is there. U is the initial velocity. If this is making an angle theta with the horizontal, then here it will be u cos theta and here it will be u sin theta. So we can write this as ux equals u cos theta, that is along x-axis. This is ux equals u cos theta and uy equals u sin theta. Right? The same way, if the object is in an inclined plane, suppose here this is making an angle beta. This is the inclined plane. Here the object is giving a projectile motion. Okay? In this case, if it is making an angle theta, here we should consider acceleration will be acting vertically downwards. This is the velocity. Here which and all we can consider it as components. Okay, this is the initial velocity which is acting. So we will consider this as our x-axis and this as our y-axis. Okay, so these two will be this is x and this is y, and next we can consider u as ux, u cos theta in this direction and u sin theta in this direction, right? That is uy will be in this direction. Now when we are considering the acceleration is not acting just exactly perpendicular to this x-axis. Here means acceleration is acting exactly perpendicular downward direction. But here plane itself is inclined plane, right? So acceleration is not acting exactly perpendicular to it. Acceleration is making an angle theta with the y-axis and x-axis. Okay, so here this will be acceleration along y-axis and this will be the acceleration along x-axis. So acceleration graph, it's acting exactly downwards, acceleration, but here the components will be one along this axis and the other along this axis. Okay, here this will be ay and here it will be ax. So here this is making an angle beta, right? With respect to horizontal, inclined plane is making an angle beta. Therefore, this is the corresponding angle. This will be beta. Therefore, ay equals a cos beta and ax equals a sin beta. So here we are considering we are getting ax, ay, ux, uy. So here we got the ax value and ay value. Now we are considering whether it is positive or negative. So here ay, it is acting downward direction. Therefore, ay will be a negative value. Ax is acting in this direction. So ax also will be a negative value. Now we are going to write down the ux equals, what is ux here? U cos theta and uy will be equal to u sin theta. Okay, this is how we will be finding out the acceleration component and velocity component. And here we wrote the velocity component. What about the acceleration? Acceleration along x-axis. Acceleration along x-axis is 0 over there. Acceleration along y-axis is equal to minus g. So this is how we will be finding out the components. After finding out the components, to the respective value, we can substitute any one of the equations of motion. If we want to find out the height of the tower, those cases and all, we will be considering y-axis. If they are asking us to find out the displacement from the original position, so we will be considering the distance and along the x-axis we will consider. Okay, so which equation we should choose, that and all depending on the question they are asking. So here we can substitute the three equations of motion: v equals u plus at, s is equal to ut plus half at square, and then v square equals u square plus 2as. Any one of the equations of motion we will apply. If it is x-axis, along x-axis, velocity along the x-axis, its required means we will find ux axt, sx ux half axt square. Like that we will take the respective components we will be considering. Okay, so here initial velocity along x-axis and y-axis, acceleration along x-axis and y-axis. In the case of this inclined surfaces, you should consider the inclined surface as x-axis, and perpendicular to that you can consider it as y-axis, and respective initial velocity components and acceleration components we can consider and find out the and can solve the problems. Okay, this is the theory behind solving such kind of questions. Okay, now we will go through the problem. So here the first question is, a projectile is fired horizontally with velocity of 98 meter per second with from the top of a tower from the top of a hill 490 meter high. So a projectile is throwing with a velocity of 98 meter per second horizontally. Okay, and then from the top of a hill of height 490 meter. Find the time taken by the projectile to reach the ground. So first we need to find out the time, the distance of the point where the particle hits the ground from the foot of the hill. Okay, so distance from the foot of the hill we need to find out, and then the velocity with which the projectile hits the ground. So with which velocity it is hitting the ground. So the object is throwing with a velocity 98 meter per second and it will be moving like this. It is horizontally moving. Right? At this point, what will be the velocity? That is final velocity we need to find out. Okay, here the time that it reaches the ground. Time it is reaching the ground means here it is starting with a particular velocity. So initial velocity we can write it as u equals 98 meter per second, which is acting along x-axis. It is throwing horizontally. So whether any velocity vector is there along the y-axis? No. Therefore uy equals 0. Whether acceleration is acting along x-axis? No. But along y-axis acceleration is acting, that is g. Here yes along x-axis we don't know, and yes along y-axis we know it is 490 meter. That is y-axis is this and this is the x-axis. Okay, s-axis distance also we need to find out, distance from the foot, that one we need to find out. Now we require time required to reach the ground. So it will be covering this much distance and will be reaching to the ground. So S is equal to which formula we can apply? Sy equals uyt plus half ayt square. Okay, here 490 equals 0 plus half 9.8 into t square. Therefore, this is 4.9, t square equals 490 divided by 4.9, Therefore 4900 divided by 4900. Therefore T, we are getting it as 10 seconds. Next we need to find out the distance from the foot. So now you got an idea, I think, because since we are finding out the time required to reach the ground, we should consider the downward motion, vertically downward. Downward means it's along the y-axis. So we are considering only for y-axis, and we got the first one answer as 10 seconds. Next is distance from the foot of the hill. So from here to here, that means it is along the x-axis. Okay, so S is equal to ut plus half at square, uxt plus half ax t square. Ux we know it is 98, and t already we got it as 10 seconds, right? So during that time, how much it will be covering? 980 meters. Okay, clear? So this is along the x-axis because it took 10 seconds to reach the ground. So the distance during the 10 seconds horizontally, how much it is travelled. So we need to consider only the horizontal components. Next we need to find out the velocity, with which velocity it is reaching over here. So here the velocity is like this. That means it has a velocity along the x-axis as well as the y-axis. So we need to find out x-axis velocity and y-axis velocity and can find out the resultant. Okay, resultant velocity vector. For that, first we will move to the velocity along the x-axis. V is equal to V equals u plus at, ux plus ax into t. Therefore Vx is equal to ux 98. Okay, 98 meter per second we will get. Next is along y-axis. Vy equals uy equals 0, ay equals 9.8 into t is 10. Therefore it is 98 meter per second. Now how can we find out the resultant of these two velocities? V equals root of Vx square plus Vy square. Okay, so therefore root 2 into 98. 98 square plus 98 square, 2 root 98 square. So 1.414 into 98. Okay, so 98 point something, 99 point something we will be getting. Here the answer we are getting it as 98 root 2 only, it is given over here also. That is the final velocity vector. And time is 10 seconds and velocity distance is 980 meter per second. 980 meter. That also correct. Clear, children? So this is we can easily find out the projectile motion, distance, displacement, velocity and all. We can easily find out. Only thing is we need to consider the velocity vector and acceleration vectors along the particular direction. If it is horizontal, we need to consider the horizontal direction. If it is vertical, we need to consider the vertical direction. Clear? Next question is, a body is thrown horizontally from the top of a tower and strikes the ground after 3 seconds at an angle of 45 degree with horizontal. Find the height of the tower and the speed with which the body was projected. So a body is projecting from the top of a tower. Okay, from the top of a tower, it's projecting horizontally. So it's moving with a velocity like this and it strikes the ground after 3 seconds. So after 3 seconds, it is striking the ground with at an angle 45 degree with the horizontal. So the velocity, final velocity will be acting like this. With respect to the horizontal, it is making an angle 45 degree. Okay, then find the height of the tower. We need to find out the height of the tower and the speed with which the body was projected. So u also we need to find out. Okay, so here as I said in the previous question, we can find out this, it's u and height, that is distance along the y-axis. So sy we need to find out. Sy, how we can, what is the formula? S is equal to ut plus half at square. Okay, here initially it is projecting horizontally. So along y-axis, whether there is any initial velocity is not there because the object is throwing horizontally. So uy equals 0. Now next is ay, acceleration along y-axis. Along y-axis it's equal to g, that is 9.8 meter per second square. So it's taking t equals 3 second time to reach the ground. So to reach the ground t equals 3 seconds. So we can apply the formula over here. Sy equals half into 9.8 into 3. So here 9.8 into 1.5 if you are doing, you will be getting it as 1470. 14.7 meter. Now here it's 3 square, 80 square, right? So we should multiply with the 3 also. So 7 3s are 21. 44.1 meter. We will get the answer as 45 along y-axis distance is equal to 44.1 meter. Now we need to find out the initial velocity. Initial velocity, how we can find out? We know the final, do we know the final velocity? Final velocity we don't know, right? It's velocity, it's making an angle 45 degree, that we know. So tan beta, if I am considering the tan beta over here, tan beta will be equal to Vy by Vx. Opposite side divided by adjacent side. Okay. So this is opposite side and this is the adjacent side. Vy by Vx. So here we can find out Vx as Vy by tan beta. For that we don't know Vy also. We can find out Vy because we already got the value of Sy. T is there. T is 10 second, it is there. Vy equals V equals U plus AT, Uy plus Ay into T. Therefore Vy here equals Uy equals 0. Therefore Ay is 9.8. Time is 3 seconds. So it is a 29.4 meter per second. This is the velocity vector along the y-axis. Therefore, we can find out Vx as equal to 29.4 divided by tan beta, tan 45, it is 1. Therefore, 29.4 meter per second only. Therefore, final velocity will be equal to root of Vx square plus Vy square. Both are same. Therefore, as per previous question, root 2 into 29.4 only we will be getting here also, meter per second. Okay, so clear children, that is 29.4 second with which the body is projected. So here we need to find out, here final velocity they didn't ask us. So they asked us only the initial velocity. Initial velocity Vx, if we get the Vx value, then we can apply V equals U plus AT. Vx equals Ux plus Ax into T. What is Vx? Vx 29.4. Ux plus Ax, acceleration along x-axis is 0. Only y-axis acceleration is there. So 0, Ux will be equal to 29.4 meter per second only. This is how we will be. So it's easy, right? So otherwise we will think it is along the horizontal direction, it is moving, then along the vertical direction. So that is the use of components. If we are considering the vector as components, we need to consider only that component for height. If it is height, we need to consider only y component. If it is horizontal distance, we need to consider only horizontal component. And final velocity, as like this, if they are asking, we can find out the x component, y component separately and take the resultant of those two vectors. Okay, clear children? Is easy, right? So this is how we will be solving such kind of questions. So I hope it is clear for you, and if you have any doubt, please comment it in the comment box. And these videos are useful for you, I guess. If you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.